Alright, checking along. We're doing backgrounds now. There's a lot of code to go over. There's a lot of things that I've learned. A lot of things I'm still learning. Backgrounds were pretty tough. Let's dive into it and see what happened, alright? Alright guys, welcome back to the channel. If you're enjoying these, don't forget to subscribe and like. This is a lot of fun for me, and hopefully you guys are learning too. Anyway, let's dive right in. So from the last time we talked about loading up sprites, and I want to talk to you today a little bit about backgrounds. And one of the things that I came across that I wanted to show you guys that I cleaned up a little bit was palettes. So if you remember, this is my original script, and I did a load palettes loop here, and I did a background palettes first and then a sprite palettes. And if you remember, the palettes for the background go from 3F00 all the way up to 3F1F, and then the sprite palettes continue on starting at 3F10 and go all the way up to 3F1F. So you load the first 16 bytes background palettes to fill up the 3F0 to 3F0F, and then you load the next 16 bytes of sprite palettes and they fill up 3F10 to 3F1F. Anyway, it kind of dawned on me that I could probably just combine these two into one loop, and instead of comparing it to hex 10, which is decimal 16, I'll just compare it to 20, because I'm loading up 32 bytes. So let me scroll down to the bottom and show you. So in background palettes, I had 4 data bytes for the first palette, 4 data bytes for the second palette, on and on. So I have 16 bytes of background palettes, and then I had 16 bytes of sprite palettes. So I was like, you know what, I'm going to combine these and just call it palettes. And you just have to remember, and I'm going to remember it, but background palettes come first, and then sprite palettes come right after. So that's what I did. That was the first major change that I did as I was reading. So here's the new. There's the old. I just commented it out. And forgive my code. I have so many comments in here. It may look a little hairy, but it's just so I can continue to learn and remember. Anyway, so this is my new one for background and sprite palettes. So same thing. I started off the index x at 0, and I just made another label called load palettes instead of load sprite palettes and load background palettes, whatever. So I changed my data byte to just palettes, and writing it up to the PPU, and I'm going to keep going until all 32 bytes have been copied up, and then I'll branch out. So that'll take up the 32 bytes from 3F00 all the way up to 3F1F. So I'll scroll down to the bottom, and we'll get into all that other stuff that you see up in the top in just a minute. But anyway, so I commented out background palettes, and I just put them here under palettes. So there's my first 16 bytes for palettes, because you can have 4 sets of colors, and my first 4 sets of colors for sprite palettes at the end. So there's my 32 bytes, and I just combined it. It just looked a little cleaner. I mean, you guys can do whatever you want, but it's just something I learned and something I wanted to kind of touch on before we dive into backgrounds. Just one of the changes. I was like, this would be a lot easier if I just do one loop. Maybe it runs a little faster because it's only doing 1 loop instead of 2. I don't know. Anyway, just something I kind of came across. So that was one of the first major changes. Just something kind of dawned on me. I was like, you know what? This could actually be a lot easier. So next I want to touch on the variables and the constants. Remember, I was having trouble getting this to work. I couldn't get player up, working and declared up here. I figured out what it was. So let me go over here. So one of the things that I didn't realize is when you're declaring a constant, it has to be all the way to the left. Okay, it looks like it's all the way left, but that's because I backed it up. Anyway, it wasn't all the way to the left. So there's a spacing and indentation thing that kind of goes with assembly. It's very finicky. It does not like it. So if you tab this in, it's not going to compile. So anyway, let's dive into backgrounds. So let me bring a picture. Where's my picture? Here it is. Okay. Most classic background of all, right? So if you don't know, the background is actually made up of 32 tiles that go to the right and 32 tiles that go to the bottom, and sort of a grid, it's broken up like this. So if you multiply out, here's my calculator. So if you multiply out 32 times 32, you have 1024 number of tiles. Man, couldn't think for a second. So 32 times 32, okay? So you have 1024. Now, the problem with that is this is an 8-bit system. So if you're trying to loop through, and I thought it would be this easy. It's like, oh, well, I'll just make another loop called load background tiles. And when I did that originally, this is the actual answer, and I'll dive into that in just a minute. What I tried to do originally was a simple, load loop, a simple loop to loop through and load all the tiles. What dawned on me was that when I do a compare, and I say, okay, jump out of this loop when what? When we reach 1024. Which is in hex 400. Well, on an 8-bit system, the highest compare you can actually have is, a compare of, FF, which is only 255. So when I first loaded it and ran that little loop, it only loaded 255 tiles. So if we go back here, 255 tiles is, let's see, 255 divided by 32. So it was 7, yeah. So I only had, is it still on the line? Yeah. So I only had 7 rows loaded of background tiles. I'm not going to draw all these lines. I'm ruining the best background ever. But anyway, it only drew the first 7 lines, and then the rest was all just kind of garble. I was like, what is going on? And it didn't dawn on me. I was like, oh, wait a minute. I need to get all the way to 1024. So I tried to compare it to 400, and it errored out. I was like, I don't know what 400 is. I'm only an 8-bit system, you doofus. And I was like, great. How do I do this? So I went to my trusty friends at Nerdy Nights, and I looked at their answer, and of course they explained it, and you basically have to run it through 2 loops. So in their first example, they only loaded up 128 bytes as well. They didn't, they only did like 4 rows, so they couldn't do more than 7 in their example. So it wasn't until week 8 that I saw it, I read it, and now I get it. So I'm going to try and explain it the best I can. Okay? So this is how you load a background. First of all, you do have to define your background. So go down to your organization down in Bank 1, where it starts at E0000. And this is where you're going to put your background. So think of this as kind of drawing your screen. So this entire thing is your TV screen. This is the bottom right of the screen. This is the top left of the screen. So this first data byte up here, this whole row is your, row 1, and that would be up here, and the bottom row is down here. Clean that up a little bit. So you don't have to worry about. Let me thin out the lines a little bit. There we go. So when you're drawing this out, you're going to have to be able to visualize it, and I'm looking into different tools on how to do that. But for now, let's just dive into the easy way, which is just typing it out. So I just did a Control-C, Control-V, and I just pasted all of these numbers in here. So what I'm going to do is show you my char file. If I can find it. There it is. That was weird. Anyway, so here's the background tile. So I got 25, 26, 27, 28, 29, and the rest of these aren't really used, right? I just have them as blank. So, and then I have letters and numbers and stuff like that as well. So anyway, I chose these here just to kind of, just random blocks that I kind of drew, you know. So, you know, all you got to do is reference those tile numbers. This is actually the address on your chart file. That's all you're doing, is pointing to the address. Okay. So, you know, the first 4 rows are going to be 26, and then I did the next 4 rows is 25, and so on and so forth. I just spaced out the top half of the screen from the bottom half of the screen. You don't have to do that. You can also do it so that it's a little easier to read. You can do, you know, like every 16 bytes or something like that if you want. Visually for me, it was just easier to just do the entire row so I could see the whole TV screen, so to speak. So anyway, that's what I did. So you can just label this as background and make sure it's at the top so that it is organized. You will have problems, I realize that. I put some things above the background and then declared the background. Didn't work out. So anyway, that's what we'll do here. So the whole screen has been declared. And what we're going to do is, okay. So we're going to reference all of these. So like I said, I had 25, 26, 27, 28, and I just kind of randomly did it, just, you know, so I could see what it would look like. Now, let's go to the code. Load palettes. No, we're not doing that anymore. Okay. So load background. This is my little new section. Yeah. So load background. Quick FYI, you do not put this in the NMI. We're still outside the NMI. Okay. So load background. You still want to start off by writing the low and the high bit of 2000. So you write, you know, the 20 to 2006, which is the PPU status. And then you write 00, which is the low byte, to 2006. So now you're ready to start transferring your data. So that part doesn't change. Okay. Sorry guys, I'm doing my best. This is still all new to me, so I'm just really excited too. I finally got it to the screen. I went in there and told my wife again. I was like, baby, I can now draw backgrounds. She's like, that's nice. I'm on episode 4 of Stranger Things. Can you please be quiet? So of course I paused it and it's like, oh, Stranger Things. Great show, by the way. So we're going to load 0 into A. So this is actually the meat and potatoes right here. There's an inside loop and an outside loop, and I'll explain how this works. So remember, we're limited by 255 as the maximum number that we can compare. So as you're looping through, once you hit 255, then what? Well, you need to do it again and again and again. So if you take 255 and multiply it by 4, okay, then you get 1020. Oops, not 255, 256. Why do I keep saying 255? So 256, okay, which is FF. So we have to do this 4 times. That's why there's a 4 down here on the outside loop. So what happens is the inside loop, this one right here, runs 256 times. It goes down, it compares X, which is only incremented once you get outside the loop, which is only happening when Y reaches 256. So it'll increment. It'll do it again and repeat until, you know, it gets all the way up. But let's dive in line by line. Okay. So first we're going to load 0 into A. We'll start off at A as 0, and then we're going to store A into pointer low. So at the very top, I had to make 2 declarations. So the problem is, since this is an 8-bit system, you have to point to a 16-bit address. You can't give it a 16-bit number to compare it to. So you give it an address. So we're going to declare pointer low and pointer high. Pointer low is going to be the low byte of the address, and pointer high is going to be the high byte of the address. And you just want to reserve 1 byte to store each of those variables, okay? Because they're going to be, you know, incrementing as we go along. So you make those 2 declarations, and there we go. Okay. So now we're going to store A, which is 0, into pointer low. Okay, big deal. That's 0. Okay. Now this little function right here is where the magic happens, and this is where I didn't understand. So pound high. Well, high is actually a function, and it's going to return the high byte of an address. Well, what address is it being passed? Well, background. Well, what is background? Remember, background is this section right here. So when you say give me the high byte of background, what you're actually asking for is give me the address that the last byte of background is taking up. Okay, so since this is 1024 number of bytes, this is going to be, there we go, this is going to be 1024. And that part I'm a little fuzzy on. I'm still trying to understand it. So it takes the high byte of the address, and it's 1024 bytes from what? But that's the address that it takes, and it just takes the high byte. So let's just say it's 4F00. This is going to take 4F. So that's what it's going to put into A. Now we're going to store A into the high byte. So we just took it from the background. It's 4F. Okay. Now we're going to put that into the high byte. So the high byte pointer is going to take 4F, and the pointer low is going to be 00. If it's 4F00. I'm just kind of making that up. I'll have to look into that and see what it actually is. So we're saying this section right here is basically saying what is the high and low bytes of the address that all the background needs. And we're only doing one name table. We're not even getting into scrolling and mirroring and all that stuff. Just give me the address of the last byte. Where is it? Well, it's 1024 bytes from wherever the sprites begin with. Start with, whatever address they start with. Which I don't know off the top of my head, so chew me out in the comments if you need to, or help me out either way. Okay? So now we're going to get the meat and potatoes of actually looping through that 4 times until we reach 4F00, or whatever the address is. Okay? So we're going to start off by making X and Y values 0, because we need 2 loops. One inside loop to go 256 times, and we're going to tell that loop to run 4 times. Okay? So we're going to make a label called outside loop, and the inside loop is going to be inside the inside of that. Okay, so there's the inside loop highlighted, there's the outside loop. So inside loop. So we're going to load A with the low pointer, which remember is 0 plus Y. Well, what was Y? Well, we just made it 0. So it's going to start off at 0, 0. Okay? So that's the first byte that it's going to copy in. And we're going to do that and, we're going to write that to 2007, which is where your background sprites get written to. And we're going to increment to tell it that, hey, we've done 1 byte of the background. And hey, does Y equal 0? No, because it just got incremented, right? Okay, well I guess we got to do it again. And again, and again, and again. So what happens is the next time, the pointer, 0 plus Y, well now Y is 1, because it got incremented. So now we're going to be copying in byte 0, 1. And then we're going to be copying in byte 0, 2, 0, 3, 0, 4, 0, 5. And you're going to keep going until you get to 256. And what happens is at 256, when you increment Y, what's going to happen is it's going to go back to 0. Okay? Once that happens, when you compare Y to 0, it's going to say, yes, I am equal to 0. Meaning you just did 256 bytes. So you just drew the first 256 tiles, so the first 7 rows, or 8 rows of the background. So the first time it runs, let's get a visual. So the first time it runs, you're going to get 0, 0 tile over here. Oops. 0, 0 tile all the way to 0F, and so on and so forth. You're going to get the first 7 tiles. Or 8 tiles, sorry. 8 tiles. Woo. Let's just say it's that many. There we go. So now Y is going to be 0. So when it compares that to 0, it says, oh yeah, you're definitely 0. So it's not going to branch because now they're equal. So it's going to go to the outside loop. Okay. Now what we're going to do is increment pointer high. So when you increment pointer high, it's going to start off at 0 because it's the highest value in the address. It's going to go back to 0. You're going to increment x, which is the index we're using for the outside loop. Okay, and we're going to see if it equals 4. So it doesn't equal 4. It only equals 1. This is our first time getting here. So, do they equal? No. So, I want you to go back to the outside loop. Okay, once it goes there to that label, it goes back to the inside loop. Now pointer low is going to be added to y, okay, which is now 1. Oops. So now we're going to start doing the second section, right? 1F, oops, second section of tiles. I'm doing my best to explain this, guys, just bear with me. Like I said, I'm learning. So I'm going to do this a little easier. So this is your first section, right? Yeah, good enough. Okay, and then you got your second section, you know, and then your third section. Oops, I didn't really do that evenly, but anyway, and then your fourth section. Okay. Hope that helps. So let's make this a little easier. So here's your first section. And then it'll do your second section. Then it'll do your third section. And then you'll do your last section. Okay, so it'll do it 4 times. So it'll go back to the outside loop, inside loop, and it'll keep going. So I know I kind of, you know, didn't explain that completely well. I read through Nerdy Nights. If you go to week 8, Nerdy Nights, there we go. So if you go to week 8, there it is. So they break it down and they explain it a lot better. Okay, basically what you're trying to do is 16-bit math on an 8-bit system. So because there's 256 tiles, you have to use 2 counters. One to count up to 256. And the second counter index, you're going to count up to 4. 4 times 256 is 1024. That's how you get the complete total background. Okay. So they explain that here, you know, through the whole step by step, and they can explain it a little bit better than me. So anyway, it was a lot for me to ingest. As you can tell, I'm still stumbling even through how to, you know, explain it. But they give you the samples here, and you can read through it. You know, hopefully I didn't confuse you. Hopefully that helped a little bit. So let's go back to the code, and I'll show you what happened. So anyway, so we wrote to the PPU, we set it up. We got the high and the low byte of the complete background. Okay, we looped through the first 256 tiles, and we did that 4 times. We did it once, twice, 3, 4, and then hey, they equal 4, so now we can get out of the outside loop. Okay, and the entire background will be loaded. So let's look at that first. Hopefully you guys aren't too confused. I mean, ask questions because I'm learning as I go. I really am. I'm just doing the best I can, guys. So bear with me. So backgrounds. Next we'll get into attributes. I'll show you what that's all about as well. That took a while. And that's actually more confusing. I'll do my best to explain it. Why is this taking forever? Okay, there we go. So all of these, and I'll explain the colors in a minute, but let's just take a look at the code and see how it lines up. So I'm going to put this here and this here. Okay, so we have a little hook here. Oh, my sprite's in the way. But, oh well. So we have this left little, you know, bottom left little wall corner. So that's 26. So if I roll over it, Oops, you can't see that. So if I roll over it down at the bottom, you see that that is pattern 26. So that's the first 4 rows. Don't worry about the colors. I'll explain that in a minute. That's attributes. So then the next 4 rows is 25. That's this one. So that's the double bars. You know, that's 25. And then the next one is 27. These 2 sets here is 27. Right there. And then let's see, 28 is this one right here. It goes left to right instead of, or horizontal instead of vertical. And then I just kind of repeated it, you know, 26, 25, you know, 27, 28 again. No big deal. Okay, so now we have a whole background. Yay! So, how do we get it to be colored? Now, this part I may just, I'm gonna do my best. Okay, I'm already, as you can see, I'm already stumbling around. Basically, to make this part simple, guys, it's 16-bit math, so you need 2 8-bit loops to do it. Period. Next topic. Save you 20 minutes of headache. Just skip, put it in the video, skip to 28:39 or whatever this is going to end up being. So now you need attributes, and the attributes are going to tell the system how exactly to color, to tell it which palette to use. So the attributes are very interesting, and this is why it took me almost 3 weeks to do this video. I'm going to do my best. Okay, let me go back here. So if you go to week 5, week 6, backgrounds. Now, if you read this, you can read this over and over and over again, and it still may not make sense. Okay, so there's a grid, and the 8 attributes can only be applied to a certain area. So if you look at my, picture here, only certain, 2x2. See this little 2x2 area right here? There's a 2x2 area. There's a 2x2. These little 2x2 areas, that's the smallest area that you can have up to 4 colors. Okay, you can't have more than 4 colors on any 2x2 grid, because those tiles all have to have the same color. Okay? Alright, now let's have a little fun. Let's make all 4 of them the 3rd palette, just so that you can see the difference. Maybe it'll make more sense if I do that and play around with it. Okay? So the first one, we're going to make the 3rd palette. Second one, yeah, there we go. We'll make all of them the 3rd palette, just to have a little fun. Okay? I'm a visual guy. I need to see it. And I know I'm not explaining this best, I'm doing my best, guys. I'm very sorry, but I just wanted you to kind of enjoy my learning. You can laugh at me and laugh with me and whatever. It's a lot of fun, though. I love it. Okay, so we picked all 4 squares to get the 3rd palette. Maybe that helps a little bit. Okay, so now you can visualize it. Let's do this. Let's make the 4th one. Let's have a little fun. So the 4th one we're going to give... let's get rid of all this. Okay. The 4th one we're going to do 1 of each. Okay, we're going to do 0, 0, 0, 1 for the second one. It's going to... second tile set of 2x2 is going to get the 2nd palette. The 3rd one is going to get the 3rd palette, and the 4th one is going to get the 4th palette. So let's see what this looks like. So we're going to save it. We need to close the game. We're going to make this game black and white. It's going to look like Game Boy. Actually, Game Boy is more green, but anyway. Okay, there. Now you can actually see the difference. Okay, so 1 attribute byte controls a 4x4 section, and each 2x2 tile, okay, each 2x2 tile can only have 1 palette assigned to it. Okay, so in this case, the green, right? Let's validate each one. I'm going to go through this because this is how I'm learning too. So let's figure it out. Which one of these is actually the first one? 0, 0. Okay, well, what is 0, 0? 0, 0. That's the first palette byte. Let's see what it looks like. So we'll do it down here. 0F 29. Oops. 29, 1 alpha, which is I think this one. Yep, 1 alpha, and 22. Okay, so the purple, green, purple, green. Okay, so which one of these has purple, green, purple, green? The bottom right. Okay, so if you're looking at this tile, this bit, so it goes bottom right. We're just going to document it. So the first 2 bits are the palette that gets assigned to the bottom right section of this, 4x4 tile area. Okay, and which one got 0, 1, which is the second palette. So let's check again. 0F, 36. Which one is 36, 17, 22? Okay, there we go. So which one looks like that? The one next to it. Okay, so this is, so it goes bottom right, bottom left. So bottom right, bottom left. I'll re-explain this in just a minute, guys. I'm sorry. Like I said, I'm learning. You guys are with me. You're probably rolling your eyes like, oh my gosh. I thought about it too. I was like, should I try and figure this out and then do the video, or just do it? I'd rather just do it so you guys can see what I'm struggling with. As you can see, attributes, I'm still learning. Alright, so the bottom right got 0, 0. That one. Then the bottom left got that one. So which one got 1, 0? Which is this one. So which one looks like that one? That's what I want to find out. So, do I have one made that looks like that already? 30, 21, whatever. Oh well, let's make one. So 30, I'm sure this gets easier, and like, it just gets simpler for people. For me, I'm still kind of winging it, 22. So which one looks like that one? Okay, the blue, white, and purple. Okay, so that's top right. So then comes top right. And of course it should be top left is the last one, but we're going to validate that anyway. The top left one should have gotten, that one was black and white, I believe. This one? 2010 0, 2010 0. Yeah. So am I right? Does the top left one? Yep, top left one is 0. Okay. Shoo! Alright, let's do a quick rehash. Okay, so so on this one right here, I decided to, the first one gets 0. The second set of tiles gets 1. The third set of tiles gets 3. And the fourth set of tiles gets 1, 1. There we go. Okay, now, what order are those? Well, the first set of tiles, which I gave 0, 0, is actually the bottom right. Then it goes bottom left, then top right, top left. So it's kind of like right to left, right to left. Okay, that's easy to remember. Right to left, and then right to left. Cool. So anyway, that's how attributes work. Oh my gosh, that was harder to explain than I thought. Anyway, guys, that's how you do attributes. So you only need 64 bytes because since it covers a 4x4 tile, 64 bytes will cover all of your screen. So if you do 64 times 4, that's all 256 tiles. Because remember, there's 32 tiles across by 32 tiles up and down. Okay. My goodness. So that is background. That is attributes. Okay. Man, I hope I didn't, really confuse you guys. I'm gonna look at this video and probably just cringe, but I wanted you to kind of go through it with me. The hardest part to understand for me was attributes. This part, not too bad. It's like, okay, I'm getting a high byte address of background. I'm starting the low byte at 0, and I'm looping through this 256 times. And I got to do that 4 times to get all, to get a 16-bit address, 1024. Anyway, I'm still having difficulties. But anyway, those are the things that I've changed. As you can see, I can now make a background. I can color and specifically get which, 2x2 tile to color. This does add some limitations. You got to start thinking about what and where you want to put tiles, because if you put them right next to each other, So this has been a lot of fun, guys. I know I had a lot of struggles to try and explain this. I'm doing the best I can. Hopefully you guys are learning. Like and subscribe anyway, because I'm going to keep doing this. My next goal is going to be, let me get a YY chart up here. So as you can tell, I'm doing a single screen game. I am not going to be doing any kind of scrolling. Oh, I forgot to cover that. There's something else that I learned on one of the tutorials. Where is it? Attributes. I combine the palettes. What else was it that I... Oh, there it is. Okay. So right here. At the end of your NMI code, if you're doing a single screen specifically, from what I read, you have to do this. You have to tell the PPU status that you are not scrolling. You're basically saying, hey, the pixel that's supposed to be in the top left is still supposed to be 0, 0. Okay, don't move it over to the right or left. You know, unless you're scrolling, of course, then you might want to do that. So let me explain that real quick. PPU register. Yeah, here it is. I was reading this earlier. So the scroll, which is PPU, the PPU scroll, which is at register 2005, address 2005. You have to write to it twice, okay? And that's why I have, written to it twice. So I want to store what's in A, which is 0, to 2005 twice. So what you're doing is telling it the position. So you're telling the PPU which pixel of the name table selected through PPU control should be at the top left corner of the screen. So I'm telling it I want 0, 0 at the top left. I don't want 8, 0 or 8, 8 at the top left. In other words, I don't want the screen to have moved over 8 pixels. I don't want that. I want it to stay still. So at the end of each NMI, I was like, that, make sure 0, 0 is at the top left. Don't go running off doing whatever. Okay. That was one thing that I, kind of came across. So make sure you put that in there if you're doing a single screen. The other thing is LDA. The other thing is when you're writing to the PPU for 2001, which is the status register. Let me go up here and I'll show you that. So here's the mask. It's PPU mask. Sorry. So one of the things I had to change is these 3 right here. So on my first one, there it is. I just had 1 0, 0, 0, 0. I just want to enable sprites. Well, now you want to enable backgrounds. So show sprites is there it is. Show sprites is the 4th bit. Okay, I already do that. 1, 2, 3, 4. Cool. Now I want to show the background. So I had to turn that one on. So 1, 2, 3, 4. Turn on sprites. Now we turn on background. Well, there's 2 more. I also wanted to show sprites in the leftmost, 8 pixels of the screen, and show backgrounds in the leftmost 8 pixels of the screen. The reason you want to do that is because you don't want it to clip, on the left side of the screen. There might be reasons you want to do that. I can't think of any. I'm sure there are people who can. I didn't want any clipping. I didn't want any cropping, nothing. I wanted the full page of tiles, all 256 tiles available to me. So, I turned that on. And then grayscale, just, whatever. I left that off. I don't want grayscale, maybe if you're making a Game Boy game or something, or a game to look like a Game Boy game, you'd use that. I don't know. And then to emphasize red, blue, and green, I just left those off as well. So anyway, that was the other thing that I changed. And then also wanted to write to the PPU and say, hey, pixels should be, the 0, 0 pixel is what I want in the top left screen. Don't move the screen around. Okay? So you have to do that at the end. So I changed it in 2 spots. You have to do it at the end of all your code, before the NMI, and then at the bottom of your NMI. Okay? I'm not sure why you have to do it at both, but that's all the examples kept showing, so that's what I did. Anyway, guys, I am done. I think that's it for today. I think I've confused you enough. How long did this take? A lot of the questions seem to be focused that I got in the last 2 videos on how long this has taken me, how much time am I spending. Honestly, life happens. I got my wife, I got my job, I got other things that I'm doing. other hobbies and playing a lot of games. Mario Maker 2 is taking up all my time. You know, there's a lot of other things I'm doing, and honestly, I'm only spending about maybe 10-15 minutes a night on this, just kind of reading and more reading and more reading. You know, and after about 3 weeks of 10 to 15 minutes a night, you know, I finally get it. I can't explain it, but I get it, and visually I can understand it. You know, these attributes, where they are and what they do and what area of the screen they modify. So I'm getting that. Cool. So the time, I probably could have just binged through this and understood it in maybe 2 nights. You know, if I really hit it hard and say, okay, 3 hours tonight I'm going to read, tomorrow 3 hours I'm going to read, and yeah, I could get it. So, you know, don't be discouraged. Don't be, oh, I can't do this. You know, it's taken this guy 3 weeks. I've never coded ASM assembly in my life. So this is all new to me. I'm just getting hit with it, but it's exciting, it's fun, and watching the screen actually change colors and do what I want it to do is exciting to me. I'm eventually going to be able to, you know, figure this out. So the next thing I want to do, the next iteration, obviously, is I want to be able to start moving the sprite. I can draw a background. Now I want to be able to move the sprite around on the background. So that's what I'm probably going to do next, and so that'll do, that'll cover, you know, controller inputs. So that'll be my next big topic. And thank you so much for watching. Like and subscribe, and I will see you on the next video. Laters.